Hi, Chem team. Because chemists don't want to waste any of their reactants, it's helpful for them to know whichever reactant is limiting. That is, whichever reactant will run out first. So for example, if we had 14 grams of methane and 26 grams of oxygen to combust, it would be helpful for us to know which of those would run out first. So to do this, we'll just consider each of our reactants in turn. We'll start with methane. In each mole of methane, there are 16 grams of methane, which we get from the periodic table. Then we know that for each mole of methane, we're going to need 2 moles of oxygen molecules, 2 moles of O2. And that information just came from our reaction. We can see up here that for every molecule of methane that we're using, we're going to need 2 molecules of oxygen. Therefore, 1 mole of methane would require 2 moles of oxygen molecules. And last, we can convert the moles of oxygen into grams of oxygen because we know that 1 mole of oxygen molecules must weigh 32 grams. That information came from the periodic table as well. When you crunch these numbers, you would see then that we would need 56 grams of oxygen, which you'll notice we don't have. We only have 28 grams of oxygen. So we don't have enough oxygen to combust all of our methane. We would run out of our oxygen before all of our methane had combusted. So oxygen would be our limiting reactant. So then if we wanted to find out how much of the 14 grams of methane we would actually use, what we can do is we can convert our 28 grams of oxygen and see how much methane it requires. So we'll go through a similar process. We'll convert our grams of oxygen into moles of oxygen, knowing that there's 32 grams of oxygen per mole. Then we know again that there's 2 moles of oxygen going to be used up for every mole of methane being used up. And last, we can convert the moles of methane that we'll use into grams, knowing that there's 16 grams of methane per mole of methane. And so when we crunch these numbers, we'll see that we only would need 7 grams of our methane, and so we would have 7 grams left over. We started with 14 grams of methane, but we're only going to need 7 of them. So 7 will be left over. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.